Hello, ladies and gentlemen. This is Pre-Calc Lesson 75. We are going to talk about combinations. We have previously talked about permutations, and we are going to compare it to combinations. Okay, so a permutation, or we could call it an arrangement, is ordered. That's the key phrase. It is ordered. This means we have more options if we are permuting something, okay? In our notation, we have NPR, which is n factorial over n minus r factorial. This is saying we have n things and we're arranging it in r ways. Combinations are not ordered, and this actually gives us less options, as you will see. And we write it as NCR, which is n factorial over n minus r factorial times r factorial. Notice the differences between these two. There's an extra r factorial in the denominator, which the extra r factorial, so dividing by r factorial, removes the effects of order, meaning that it's just no longer ordered. Now, this we also can see will clearly give us less options because our denominator is now bigger, right? Instead of just having n minus r factorial, we have n minus r factorial times r factorial, meaning our denominator is bigger, so our whole fraction is smaller. Now, let's look at our notation. Okay, we have permutations versus combinations. Permutation, we have NPR, and combination, we have NCR. Okay. We can also write it as PNR or CNR, or PN, R, CN, R, P, NR, C, NR, or we actually can just write it as NR for C. Okay? Any of these options, if you see it, you need to know what it is. You need to be able to recognize what each of these are. Okay? Now, let's look at specifically NCR. Okay? This tells us we are selecting n items r at a time. There's my r at a time. I'm selecting n items r at a time. Or we could say not selecting n items, n minus r items at a time, which means NCR equals NCN minus R. Those are actually the same, which can help us, okay, in different problems that we are doing. So let's go ahead and do an example. Example 1. In how many ways can a committee of 5 students be selected from a group of 12 students. Okay, so what we are doing is first let's look at the number of permutations, which is we are taking 12, we have 12 people, taken 5 at a time. So we can do 12 times 11 times 10 times 9 times 8. This gives us 95,040. Okay, but we remember for permutations, we have to divide by 5 factorial. So we will really have 12 times 11 times 10 times 9 times 8 divided by 5 factorial, which gives us 792. And that is our final answer. Now, we know that we have to divide by 5 factorial because there are 5 people in each committee, and order does not matter in a committee, right? A committee is a group of people all working on the same thing. Order doesn't matter. We're not talking about the head of the committee or not. Okay. Now, what we're doing, okay, is that we have an unordered set of 5. We leave behind an ordered set of 7. Thus, the number of combinations of 12 things taken 7 at a time is also 792, right? If we did a combination, the number of combinations of 12 people taken 7 at a time also equals 792. Just a fun way to look at it because that is how we are doing that is this. Same thing. Okay, just showing you the 2 different ways. Okay, let's do another example. Okay, if we had a circle and we have 7 points, 1, 2, 3, 4, 5, 6, 7 points on a circle, how many different triangles can be drawn using these 7 points as vertices? Here's an example of one triangle. Okay, we want to know how many can be drawn. Okay, so first we find the number of permutations of 7 things taken 3 at a time, which means we do 7 times 6 times 5, which gives us 210. Okay, now every time the same 3 points are used on the circle, it gives us the same triangle results. So the order of the points is not a factor. So all we do is we take this and we divide it by 3 factorial, and this gives us 35 different triangles. Okay, let's do one more example. How many different 5-card hands can be dealt from a deck that contains 52 cards. So we first do the number of permutations of 52. 52 cards chosen, 5 at a time. So 52 times 51 times 50 times 49 times 48. Okay? And again, it doesn't matter, right? To find each combination of cards, we do divide by 5 factorial, which ends up giving me 2,598,960 possible 5-card hands. On something like this, definitely use your calculator. Okay? Now, remember, if you have any questions at all during the video, you should bring it to class tomorrow, and we will go over it. I will go over these again in class tomorrow to make sure we fully understand, okay? But this is all we have in the video for now, and I will see you tomorrow.